Hello everyone. Today we are going to talk about the important concept that is supervised learning and unsupervised learning and how it is going to impact in petroleum engineering. So this is the concept today we are going to discuss about. So first of all, before entering into this topic, we need to know what exactly, where exactly the supervised and unsupervised learning can be. Can be. This is the birth of this particular area. That is what we say, machine learning. So, machine learning is a kind of concept where we will train the data set, where the software will get trained, and it is going to provide you the outcomes based on training. So there are two types of training we are going to provide. One is supervised learning and another one is unsupervised learning. So in recent years, machine learning has become an increasingly important tool in the field of petroleum engineering. So machine learning algorithms can be used to analyze large amounts of data, identifying patterns and trends and make predictions. So this is used to, like these are the common things that oil and gas industry will be generally taking forward to. So earlier it was done manually, but because of machine learning, this can done with easy ways of understanding this data. It is difficult when you do it with manual way of predicting. Why? Because we require large amount of manpower. So when you have softwares like these things, when machine learning is included in the software, then definitely large data set trends patterns can be easily understood. By using these algorithms, engineers can make more informed decisions about drilling production and reservoir management. So drilling production and reservoir management, these are the three. It is not just about these three things like finance side, exploration side. You can include n number of parameters which have constraints about these data sets. Like machine learning can be used in all these areas. So where we can able to include supervised and unsupervised learning to get effective outcomes. So supervised and unsupervised learning are two common types of machine learning. Supervised learning involves training a model on a labeled dataset where the desired output is known. So the difference here, it was actually it was they were telling about that. So labeled dataset, like you already know what kind of outcome you are expecting from. So that is what supervised learning is all about. So you have a data set and you know the result could be in particular range. So if you know that, that is known to be supervised learning. If you don't know it, you have random sampled data, then you are trying to find an outcome through that samples, then we say that as unsupervised learning. So we're going to see that first of all. So complexity will come with unsupervised when it comes to when you compare with that with supervised. Supervised is something that we go with linear way of understanding. So you might have one logic behind supervised learning. So if you know that logic, so you know that the outcome is going to be in so and so range. So that is what actually is supervised learning. Okay, so the model can then be used to predict the output for new unlabeled data. So we are going to train data in supervised learning by providing some mathematical regression. So based on that, it is going to provide you outcome, that is the new unlabeled data set. So we are going to see whether the values what you have predicted is matching or not. So unsupervised learning, on the other hand, involves finding patterns and relationships in unlabeled data without a specific output in mind. So it's random. Like random data was provided to you. You don't know what could be the outcome. It could be of any outcome. You don't have any idea about that. If that is the case, then whatever trained data set is going to provide you, it is going to create some kind of relation between the data. So imagine you are handling some million points. So each point might have some relation, like it is not like everything will be random, but there could be some possibility of relation between certain points. So this is those points alone can be taken into consideration when it comes to unsupervised learning. Why? Because when you want to check any random data with the provided billion points or something, so you can relate to certain criteria of a pattern which was recognized in that data set. So this is also like how you are going to do that is an algorithm. So we are supposed to understand how it can be done. So supervised learning, as I said, so these are the examples where supervised learning is going to be useful. So there are a number of applications are there in petroleum industry. Supervised learning is something that doesn't require, much advanced softwares. Like even, normal way of understanding that itself can, if you know basic mathematics, we can able to go with supervised learning. Supervised learning is a type of machine learning where the algorithm is trained using a labeled data set. So petroleum engineering supervised learning techniques are used to predict reservoir properties such as porosity. So where supervised learning is used to estimate porosity, permeability based on well logs and seismic data. So when it comes to regression, so regression is a type of supervised learning, as I said earlier. So linear regression will be there, logistic regression will be there, used to predict continuous variables such as porosity and permeability. So in petroleum engineering, regression algorithms are used to predict reservoir properties based on well logs and seismic data. So there is huge prospect for such kind of techniques where we are going to apply in oil and gas industry. So these are all important parameters where we are going to use supervised learning to estimate that. Classification is a type of supervised learning technique used to predict categorically variables such as lithology, fluid type. So in petroleum engineering, classification algorithms are used to predict rock type and fluid type based on well logs and seismic data. So classification regression. So classifying reservoir into different divisions, that can also be possible by that. So unsupervised learning, that as I said, it is a bit complicated. Why? Because we are with random points. We don't know what will be the outcome. So based on that, this is one of the most important area in petroleum engineering. Why? Because petroleum reservoirs are heterogeneous. We don't know what could happen tomorrow. You may have data today, but based on that, what is the data that can be predicted for tomorrow? It could be for future. It could be for 5 years from now. So the data was available up to now. So on basis of this data, unsupervised learning means you are going to include some techniques in unsupervised learning to estimate, to predict the parameter data for the future. So this is where exactly we are going to use, unsupervised learning for petroleum engineering. Why? Because reservoir models will be there. Life of reservoir can be predicted. Earlier also this thing have been done with some techniques. So right now we are going to integrate these techniques with unsupervised learning. So after artificial intelligence came into petroleum engineering, so we can include our known techniques into unsupervised so that we can predict what could happen in future. Why? Because this is based on reservoir projects. Like if a project has to be, approved, it has to be appraised in a positive way. For that, we need to know how best production can happen at a particular point of time. So one among that is cluster analysis, clustering. So clustering, imagine we have reservoir is like very big, huge. It will be a size of small city inside the subsurface. So if you want to estimate certain parameters all through the reservoir, it is not possible. Maybe you might have data randomly, certain wells will be there. In a big reservoir, you may have 20 or 30 wells data is there, but in between lot of space is there. So in that space, crude oil is available, but we don't know the parameters related to that. Then we have to go for cluster analysis. Why? Because you cannot drill the again another well and start extracting core samples and doing experiments in laboratory and getting the results. That is not possible. Only the way which is possible is to simulate this data. For simulation means like you already have the data, but there is a gap in between certain space that is in between two wells. So two wells or three wells or whatever wells are there. So you are going to collect available data, and we need to cluster these data so that these clusters, I will tell you how clusters will help you to locate a particular value in a particular location. So this is the reason why cluster analysis is very important for petroleum engineering, that which comes under unsupervised learning. So dimensionality reduction. So imagine more and more dimensions are there. You can reduce like X, Y, Z axis. When you reduce dimensions, then you know, your predictions will become easier. So that can be done by principal component analysis, anomaly detection. So like this, we have number of techniques that will be helpful for petroleum engineering. So application part of machine learning has various applications in petroleum for reservoir characterization to production optimization. If you see future with AI in petroleum engineering, it has huge scope. So lot of things up to now manually which have been done that can be integrated. It could be of any area, reservoir characteristics, production optimization, drilling automation. So there are lot of areas are there where you can include AI. So challenges at the same time, challenges also we have data quality and quantity. One of the biggest challenges in using machine learning in petroleum engineering is the quality and quantity of data which is available. So first of all, it is not that the data what we got it, how much qualitatively it is accurate. So that is the one we are supposed to see. When it comes to quantity, whether the quantity is enough to predict the outcomes. So that also has to be seen, which is a very big challenge since data availability is not that feasible. You need to collect the data, accurate data, and with that accurate data, you can use these models to predict, nearby missing data. The industry generates vast amount of data, but much of it is incomplete, inconsistent, or of poor quality. So you can understand right now why we are talking about data more and more about when it comes to machine learning. Why? Because data is not complete. You cannot collect it. Always there will be a gap. Quality problem is there. So for that we need two ways of understanding. One is the technique what we are going to use to simulate the data to get the missing data which is unavailable. Second thing is you need domain knowledge of petroleum engineering. So the data what you are generating through this technique, we can't say that could be accurate. Only if you know the limitations of that data, ranges of that data, why that data could be possible for that location could be, that is also an important reason. So this kind of knowledge that can be inbuilt, I mean, it will be developed while gaining the knowledge in petroleum engineering. So petroleum engineering discipline with unsupervised learning, you can able to fulfill that particular area where the data is missing, and if the data is uncertain, you can able to predict the reason also for that. So interpretability and explainability. Another challenge is interpretability and explainability of machine learning models. In many cases, it is difficult to understand how a model arrived at its conclusions, which can make it difficult to trust the results. This is particularly important in petroleum industry, where the consequences of incorrect decisions can be significant. Obviously, why? Because understanding the data and taking the decision is something more challenging. So you need to be in a way how you are going to interpret. So when you do take wrong decisions, then consequences will be deteriorating. Domain knowledge. This is one thing which is very important. Finally, machine learning in petroleum engineering requires a deep understanding of domain. Without this knowledge, it is difficult to identify appropriate data sets, choose the right algorithm, and interpret the results. So one have to possess knowledge in petroleum engineering as well as in artificial intelligence like machine learning unsupervised. So machine learning unsupervised learning is something, the technique will be there, it will not change, but domain knowledge is very important. Why? Because this can be inbuilt with understanding the concepts of petroleum engineering. Only the person who have good knowledge in that could able to integrate these two things. This means that machine learning in petroleum engineering is often most effective when used in conjunction with human expertise. So as machine learning continues to advance, there are several promising areas where it could be applied in petroleum engineering. So one is enhanced reservoir characterization, optimized drilling and production, automated decision making. So let us talk few examples of supervised learning. So you can see on the right side there is a table where the sizes of volume. Size means here you can take the volume. So this is an example of supervised learning. This is a simple example. So you can see the size is there on the left side of the table, and corresponding to that size you have price values in dollars that was given. So like you can see, so 1,000 barrels BBL of oil you are having. If you sell this 1,000 barrels, you can able to gain $300,000 in return. So in the same way, 1,500 barrels you will be getting for $420,000 in return. So this is the data that we have. As per the data predict As per the data, predict the price for the oil produced for 4,000 barrels. So you have a data and it is asking a constraint, like if you are producing 4,000 barrels, so what could be the profit or what could be the revenue that you are going to expect? So here revenue, you can see there are two things we can understand. That is what actually is about. Why it is supervised means, this is going in increasing order where the value of what you are putting over here is greater than the value of what you are putting. So we have some logic here. So when barrels of price is increasing, automatically the revenue is also increasing. So you know that if the price is more than the table data set that you have, the amount, sorry, not price, the volume, if it is more than the tabled volume, that is the labeled data set, then you can expect the value is also to be more than the labeled data set. So that you have an idea that what could be the outcome. It cannot be less than the last value is $710,000. It cannot be less than that. So it is more than that, but we want to know how much it is more. It could be 80, 72,000, $72,000, $720,000, or 730. We don't know. So we need to determine how what could be the outcome for it. Is not just about 4,000, it could be of any number. Okay, this if you could able to find a model, like we need to fit a model in this data to predict that value, that outcome value. If you could able to do that, we say that as supervised learning. So for this, let us go and solve this in MS Excel. So Excel is a good tool to find supervised model. So I already kept the data that we already I'm showing in the presentation. Whatever data is there, I already kept that data. So I'm going to make it like a table. So per every barrels of oil you are producing, the amount of this one. So right now we need to get the value as per the constraint 4,000 barrels. So this is the one you are supposed to get the outcome of price. So how we can able to get the outcome of price? So you're going to train or you're going to use a model to fit that data. So Excel itself has a model. Like when you talk about Excel, Excel is a tool where it has predicted models inbuilt inside it. So if I could select all the data, so from there onwards, I want to predict the data of 4,000. So let me check. So this is the steps that we have: 1,000, 1,500, 2,000, 2,500. So when I am selecting all this data, so it itself, Excel itself have some kind of data. I selected almost 5 data. So based on this 5 data, it will start giving you a prediction that your next step value could be equivalent to 825,000 barrels. So this is one prediction. This is what we say supervised level. We don't know how it has predicted. Why? Because it itself has a model. Okay, it was encrypted with that model. But right now I'm going to provide you a proper model, like mathematical model, which we will use in supervised learning. So let me, this is the one that we got it through Excel. I will try to make a separate color so that we can keep a check on it. So this is the model that we got it through Excel, supervised that one. So let me go with proper model of it. So I'm going to select full data. I'm going to take size barrels of oil as x-axis, and the prices are all on y-axis, and I'm going to insert into a coordinate axis graph, scatter plot. Insert a scatter plot. So you can see there are few points. So you can see x-axis was there, y-axis was there, and we can have a few points. So I'm going to label all the values. So I can remove this. So what is your x-axis? That is size in barrels. When it comes to y-axis, that is price in dollar. Okay, so let me take the grids. No need for any grid over here. So you can see this graph over there. So remember, we got a prediction of $825,000. That is one method in supervised learning. So let us go with another method which is more reliable in supervised learning. So we need to fit, this is like moving in the direction towards top. So you can see all the points. We need to fit this data as in a straight line, so that we have a straight line equation y is equal to mx plus c. So based on that we will try to move forward. Okay, so that is the idea what I'm trying to tell. So right click on it, just add a trend line. So you can see I have fitted a best straight line which connects all the points. So it is connecting with all the points. So when a straight line is there, you can fit this straight line into equation y is equal to mx plus c. So for that, just to go to right side, and I'm going to generate that equation, that is y is equal to mx plus c. So display the equation on the chart. So you can see there is an equation that we got in the form of y is equal to mx plus. So this is the equation model for supervised learning. Y is equal to mx plus c. Well, y is m. The value of m is 206, and the value of c is 104,000. So 104,000. Maybe if it is y-axis intercept, so we can use it as dollar. So this is the model. This is the model equation that we got. So y is equal to mx plus c. Okay. From this equation, what will be the value of price which has a value of size, that is 4,000. So size is on x-axis. So I'm going to put the value of x in this equation, and I will get the value of y from the equation that we have generated. So just I will calculate. So x value is 4,000, then you will be getting y value. So what is x value? That is 4,000. I am going to put that equation here. So is equal to, so this is the value I am getting. So let me put x value as 4,000. From this, or else I will try y, which is equal to 406 into x plus 104,000. So I'm going to get the value of it, value of y for it with the model. So that is equal to 406 into x value. X is the value that we have, 4,000, plus 104,000. So 104 triple zero. So I got this one. Then enter. So you can see we got the value of, you know, you got the value as 172, 1728 triple zero. So this is the answer that we got it for that. So everything is right. 4000, 4000, 104 triple zero. Yes. So we have an answer of 1728 triple zero. So this is the answer that we got it at 4000. So this is the model that we have generated. I'm sorry, I have done a mistake, I believe. Actually, this is not 406, this is 206. So 206, I have just made a mistake. So in place of 4, so I got the value as 928,000. So it is more than Excel predicted value. But actually we need to depend on this. Why? Because this is through the model that we have generated. So we have two predictions. One is 825,000, another one is 928,000. More accurate one is the one which we created with the model. So this is about supervised learning. So linear way of, you know, getting outcomes. You know the value. Definitely these two values are more than the value in the data labeled set. So that is the criteria that it has been followed. But these two are not same. Why? Because we've gone in two different methods in supervised learning. So we got two different results. So which one we are supposed to get accepted? So that is the one which we created the model. So this model is the one which has more accurate value than the Excel predicted values. Okay, so this is about supervised learning. So let us go back to unsupervised learning. So this is, again, it is a kind of gamble, but if you could observe this data, unsupervised learning is there. So how you are going to understand this data? This is not related to, I'm not putting any petroleum engineering example over here. To understand, let us go simply with the normal data. So we have a particular parameter of size that have different centimeters. 5 centimeter, which the size of that will possess red color. 6 centimeter red. Like that, you have different sizes corresponding to that. You have different colors related to that. So if you want to understand more properly about this data, go and construct scatter plot. So don't just right now concentrate on the scatter plot. So let me increase the size, and this is the scatter plot. Let me just, so you can see a scatter plot between sizes as well as colors. So you can see there are three set of points in between this scatter plot. Okay, three set of points. So you can see one, two, three, like that, like the one which is near to red color, another one is green color, another one is yellow color. So this is the distribution of points in a scatter plot. You have three different distinguished areas. So right now you have to train this data to know the value of a unknown value. Okay, if imagine if I ask, can you tell me the size, can you tell me the value of that parameter? What if the size is 8.5? If I say 8.56, what could be the color? So this is about unsupervised learning. Randomly you are adjusting these values. First of all, you have the values you kept on scatter plot. You know the green range where it is, yellow range where it is, red range where it is. So red range have reached up to 7, but all the values next to 7 are falling in green. Next to 10 are falling in yellow. So there is a pattern here. Okay, we need to understand that. To understand this pattern, for a particular color, you have a size which ranges from one place to another. This is what training is all about. So it will identify certain points which are similar to that. Means 9 which is close to 8 and 10. So the values which are close to 8, 9 and 10 that fall under green category. So this is how unsupervised learning will find out a pattern. I have given here simple uh, example, but imagine if you have large set of data, then it itself will try to find out a pattern. So when you arrange in scatter plot, if I simply show you a table, it looks very random. If I show like a table like this, if I ask simply what will be the range of color which is comes under 10.5 or something. So what we will be saying, we can't say any answer to that. So we need to, like, this is simple data, but if you see in a larger scale, you will be having lot of parameters. So it will find out similar values in the parameters and it will set into different points. So right now what it has happened here is, so you can see 3 points are near to one location, other 3 points are near to another location, and the 3 points are on the other location. So which are close to each other, we consider that as a cluster. So if I have to find a cluster, this is one cluster, this is another cluster, and this is another cluster. So this data can be fitted into three clusters. So what is cluster? It will be have, it is a kind of oval shape, circular shape. So where all the points inside that circular domain, those points are somewhat related to each other than other points. So this is what the cluster is all about. If a value comes close to 12.5, obviously the point lies in this cluster. If a value comes close to 9.5, the value might come near to this cluster. If it is 7.5, 7 or 6.9 or something, the value comes in this cluster. So this is how the cluster will help you to identify the outcomes by creating patterns, which is very important thing. So first of all, you need to understand you are creating pattern here, then we are finding out the outcome. So it is trying to create a trend pattern, something it is creating which is close to another point. Based on that only you have to find out the outcomes. So come to the next graph. So there is a method called k means clustering. Okay, it is a kind of algorithm which will be used to find out different clusters. So this is the method. So here k means clustering, what does it do is, it will separate all the points into different clusters by giving different colors. So you can see, forget about this, right? So blue color is for one cluster, and another cluster is like, yellow, which is close to yellow, those points are in blue color. Which is close to green, those points are in violet color. Which is close to red, those points are in red color. You can see there are three red crosses are there. These are known to be centroids. Every cluster will be having a centroid. So this red one is nothing but centroids. Centroids. So this is nothing but this one, and this one. So you have three centroids. What is the use of centroid? Centroid is the center part of a cluster. Imagine you draw a cluster. So this is center part of it. So any point you are taking it, with the help of the distance of centroid to that point, we can estimate its properties. If it is close to centroid, the properties of that point would be almost similar to your centroid. The more the distance, the less dependency. But away from the centroid, you don't have any relation with the cluster as well as centroid. So centroid will help you to understand the points which are close to centroids will be, you can almost make it equivalent to the value of centroid. So once it starts to move up with the value of the distance between these 2 points, you have to get the value little bit away from that. It will be plus or minus, or which is close to that. Okay. So this is the concept of centroid. Then let us try to understand one question. So if you have a point of size 8.5 centimeters. So you already know the data is in between size corresponding to that size. You have colors. So size is there, color is there. So right now already we trained the software with K-means clustering. So right now we are asking fit a point in a cluster or tell me the outcome of that particular point if the value is 8.5 centimeters. So 8.5 is the question that you are asking with the concepts that we have. So 8.5, if you are asking what color it could be. So when you use K-means clustering, you can see 8.5 will fit in, just use over here. You can see the blue color bubble which fits in 8.5, like where exactly it is. So you already know this is one cluster, this is another cluster, and this is another cluster. Right now 8.5 fits over, 8.5 fits over here. So what is this color? So you already know what is this color related to, that is green. So the color is green. Sorry, the color of 8.5 centimeter will come close to green. The outcome will be green. So outcome is another parameter that it is defining by training this data set. Okay, so this is about unsupervised learning. How, like, you are not directly giving the value of an outcome, but it is going to fit in a pattern. If it is cluster, it is going to fit in the cluster. Based on that, it is going to give you the outcome value. You can able to estimate, you can approximate. So based on this pattern, we can able to approximate that could be the outcome of it. Okay, this is about unsupervised. And another important thing what we can able to do is, let me just to show you one more parameter in artificial intelligence. So application of artificial intelligence in seismic data analysis and interpretation. So everyone knows seismics is the one which we are going to send sound waves into subsurface, and we are going to see the maps that has been generated, and based on that we are going to find out the patterns. So sound waves have been sent into the formation. So sometimes the data will not be accurate. Why? Because we don't know where exactly you are supposed to put the sensors. So seismic means like sensor, like geophone will be there which acts like a sensor, and so source point you are going to create sound waves over there. So sound waves will go into subsurface and it will be reflected towards a sensor, that is geophone. Based on that, seismic graph can be generated. Sometimes we don't know where exactly these sensors has to be located. Right now, because of AI, we can able to locate that in a more effective way, because we can able to get a good amount of quality data. That is what earlier we were talking about. Huge gap is there in qualitative data generation in oil and gas industry. So right now, how AI will help you to locate proper location of sensors, that geophones, so that can be possible, that is going to be possible. So let us see, there is an algorithm, that is what in AI there is an algorithm, we say that as Dijkstra algorithm. So Dijkstra is the kind of algorithm which will help you to find the best location near to where we can install the sensors. So it could be, you can give hundreds of parameters to it, you can give hundreds of cases to it. So it will work on those cases and it will finally give you the best location near to where we can able to install this sensors. Let us go into this algorithm, and we will not go into algorithm right now. We will see how this algorithm will apply, and later we will go into algorithm. So Dijkstra algorithm is a graph search algorithm that is used to find the shortest path between nodes in a graph. So graph where x, y axis will be there. If you take 3D, z axis also will be there. So this is what seismic is all about, like the location in x axis way how it has been extended y-axis and z-axis. So three-dimensional rock, that is a reservoir rock. So based on this, where we are supposed to locate, that is the most important part over there. So the graph is particularly with weighted graphs where each edge has weight or cost associated with it. So here, when you talk about graph, when you are taking a location, it will be give it might give more weightage whether that location, like, this can be defined by industry. Like, it is not that you might have 10 locations, but certain locations you have might have more weightage, certain locations less weightage. Means what? Certain locations feasibility will be more, certain location may not have much feasibility. So that can be converted into weight when it comes to AI. So it is not just about feasibility, it could be of any kind of parameter. Okay, that could be in finance side or possibility side, or anything that can be included in weightage. um, Edge has a weight or cost associated with it. In context of seismic data, Dijkstra algorithm can be used to find the shortest path between seismic stations or sensors, which can be useful for various applications in seismology and earthquake monitoring. Here are a few ways in which Dijkstra algorithm will help you to find optimal sensor placement. That is what we were talking about. uh, if you could able to locate in a proper way this sensor, you can able to predict even earthquakes. So this also will dictionary algorithm will help you to find out proper location where earthquake also can be detected, and this is seismology. So seismic tomography is a technique used to image the Earth's interior by analyzing the travel times of seismic waves. So inside the Earth, how the distribution have happened, that also can be lithological distributions or so many kind of things under subsurface that can also be determined by this between the shortest path. And seismic hazard assessment. So seismic hazard assessments involve estimating the likelihood of earthquakes of different magnitude occurring in a given area. So Dijkstra algorithm can be used to find the shortest path between seismic sources. So there are so many ways you can able to use Dijkstra algorithm for this. So up to now, I have told you the application part of it, but let us just try to understand how this is going to happen with algorithm. For algorithm, we need to take a set of nodes. Source node is there, goal node will be there. So when you see over here, so we are going to start with the here and we are going to end over here. So this is the source node, this is the end node. So this is actually what is the shortest path from here to here. This is what we have different set of locations are there in between, but which location is the shortest path to reach the goal? So it is not just about science, means it can be applied in number of areas. So right now, even though you have number of constraints in between, like you might have different paths. So what will be the best path to reach the goal node? So that means you are covering lot of area by moving in less direction. So this is what you have to understand. You kept source node one. Source node means source where the sound waves will be generated. Sound waves will be generated here, and receiver sensor will be here. Here means we have to find out. Imagine this, you need to cover a lot of location over here. So imagine you need to cover this whole location. On what way you have to go, like this way you have to cover it, or this way you have to cover it, or which way is the best way to cover complete location in the shortest path. So this is how the way it will go. As you know, every node will be having some weighted values. So we need to understand, and cost values. So we need to assign the values of each node in the form of distance of V. So V is nothing but the distance from your source node towards the path what you are moving on. And that includes the distance of the value what it is there plus the cost value. So let me just in Dijkstra algorithm, it is going to assign some bias values to all the values initial. We don't know one thing. We know cost value is known here, but we don't know that bias value D of U was not known. So for that, what we have to do is we need to give infinity values to all the nodes which are available, including the goal node. So you have given all the infinity values to all the given nodes over there. So from source node, you need to reach the path by going through all the nodes. If you see my earlier sessions, we have started moving through nodes. We started with BFS, DFS. So right now this is advanced to BFS and DFS. So the same way how we have gone through, we will go through here also. So first of all, the possibility of this node to explore, you have two ways. One is this node as well as this node. So here how we have to see is, we need to calculate the distance between this node to this node by using this formula, and the distance should be less than infinity. Then only you can assign that value. Both the distance should be less than infinity. So let me just go and calculate the distance. So 4 is the cost of that value plus distance value. Let me check. So first of all, you are exploring 0. So the cost of the value was given, which is less than infinity. So the value have gone over here. So it should be always less than d of u, that is infinity. Right now the value is infinity. So in the same way, when you come down also, cost of the value is 8, which is less than infinity. So you can assign the value. You can see earlier. See right now it is infinity. So the distance from 0 to 1 node is 4, which is less than infinity. Infinity is nothing but d of u. So if it is less than infinity, you are going to assign that value as 4. In the same way, this side also you are going to assign the value as 8. Okay, you have explored 1 and 2. In right now, what we have to see is, there is no need to bother about the node which we have explored. We can ignore this. Then we need to see the values which were explored. That is 1 here, 8 is here. In these two nodes, which one is smaller? So the one over here is smaller. From here, you need to explore. So if you have to explore, you have two possibilities. One is towards this side, another one is towards this side. So right now, the value is 4 plus 8, which is 12. That is less than infinity. So you can give the value of 2 as 12. So when you are assigning the value over here, let us see. 4 plus 11 is 15, which is greater than 8. So you need to ignore this value. So this is what it shows. It should be less than the value of that particular node. Only the value that changes is here. So I am exploring this value. So the value which was changed is 4 plus 8, 12, which is less than infinity, that we can assign. But here the value remains same. So right now these two have been explored. No need to bother about these two. Let us bother about those two values which have been root nodes. One is 2, another one is 4. Out of these two, which one is small? The fourth one is small. Why? Because it is 8, it is 12. From here onwards, if you could explore, you have two possibilities. One is 8, another one is 5. So 8 plus 1, which is 9, less than infinity. So you can give this value. 8 plus 7, that is 13. No, 7 is 15, which is less than infinity. So you can give this value. 15 is less than infinity, so you can give this value. So 9 and 15. That's it. You explore this value, ignore it. So right now we have options of 12, 15 and 9. So out of these three, this one is smaller, 9. So 9 has only one possibility. There is, yeah, you have two possibilities. One is this side, another one is this side. So let me check the values for this formula. When you are assigning the value for 6, 9 plus 2, that is 11, which is less than infinity, you can give this value. 9 plus 6, which is equivalent to 15 itself, which is 15 already over here. So you can keep the values as it is. So only the one which we selected is 11. So here, anyway, 15 is there. So the same value is there, no change. Right now, 11, 15, 12. The least one is 11. So 11 have three possibilities. One is 7, which is the goal node. Another one is 3. Another one is 6. So 11 plus 10 will become 21. which is less than infinity, you can give here 21. 11 plus 14 will give you 25, which is less than infinity, you can give the value as 25. 11 plus 15, which is 26, more than 12. So the 12 will remain 12 only. So the value will not change over here. So 11, okay. So it's right now you can see 25, 21, but 12 remains the same. So let us see for the next one. Goal value was given, but you need to explore other all values also. Why? Because since you reached goal node, it is not the end. We need to see the other values also. In this path you came, but whether it is right path to reach the goal, we don't know. So let us see the other possibilities 12, 25, 21, 15. So the possibility next, the less value is 12. 12 can explore two things, one is 3, another one is 8. 12 plus 2, that is 14, which is less than 15. So you can assign the value of here as 14. 12 plus 7, 19, which is less than 25. You can assign the value over here as 19. That's it. These two possibilities. So 2 if you explore, so this will become 19, this will become 14. So right now, leave all the explored values, go for the next one. 14, 19, 21. So which one is the smaller one? 8. So 8 is the small one, but it don't have anything to, root nodes are not there. So keep 18 as it is. So it cannot be explored. Next, the least values are out of 19 and 21 is 19. So if you explore 19, 19 has only one possibility, that is your goal node 7. So 19 plus 9, that is 28, which is more than 21. So leave as it is. So that means the ninth value will be explored, but 21 will not change. Then you are going to end the node with over here. So the path to reach from goal node to, sorry, source node to goal node is 21. So this is the path how you are going to reach. How we reach this path? 0, 8, so 8 plus 1 plus 2 plus 10. 8 plus 1, 9, plus 2 11 plus 10, that is 21. So this is the least, I mean, the best effective path. So if you start putting sensors in these locations, that could cover the most areas of this location, so in the least path. So this is about Dijkstra algorithm. Okay, so we can end up to here.